Okay, so now that we have our 4 corners created, we can start creating our first program. So to create a program, you will have to click here, add new program, link to selected robot, but we only have one robot in our station now, so it's fairly easy. It will create a program for this one. By the way, if you had more than one robot, if you right click robot here, you will see which robot is selected for this program. Again, only one robot here, so no issues. I'm gonna rename that program, so right click rename or F2 rectangle, rectangle here, perfect. Now in your toolbar you have you can choose between a joint motion, a linear motion, or a circular motion. So let's start by creating a program that is completely comprised of joint motion. To do that, there is different method to create a program. So first of all, if you were to bring the robot somewhere and simply click on joint motion, it would create a joint motion to a target, a new target that was created right where the robot was. So that's the default behavior. I personally never ever do that. I don't really know why I would. Honestly, I prefer placing my targets first and then creating my program. So considering that, I'm going to remove everything here. Delete target 5. What I would generally do is select corner 1 here, press Control, select rectangle here. So I'm going to select the target and the program, or the other way around, select the program, select the target, doesn't matter. And then I'm going to add the joint movement to the program. So this way it will create a move J to corner 1, which is the target I have here. If I was to bring the robot anywhere, right click run or double click rectangle, that would bring my robot to the position here. By the way, if you were to right click run, the robot will do the motion, but you won't have any slider at the bottom of your screen. If you double click, now the slider will appear and you can pick that slider up and kind of rewind the path step by step. Once I have my first move J to corner 1, I'm gonna, okay, but before we even talk about that, so by default RoboDK, if you don't have any tool or reference frame set in your program, it will automatically create a reference frame and a tool, so it will select the ones that are active. By default, in this case, we only have one tool and one reference frame, and they are both active, so the choice was pretty obvious. But in the contrary, if you had more than one, it will select either the one selected, or if you had no one selected, it will select the one activated, and if there was any activated, it will simply select the first one it sees. So continue, select control, select rectangle, press control, and corner 2, and I'm gonna go and add a joint motion. It will create the line here in between. You can see this is a joint motion, so it will simply pick the fastest joint route, so the one requiring the less joint motion. So that will often create some kind of curve more than the line, so just be aware of that. This is a fairly standard robotic behavior. If I was to add another joint motion here and another joint motion here, and select that like this, go down, rotation, double click again. So that's following the path that we were expected to follow. Remember earlier when we moved the robot around? So this is the origin of the station, and now we move the robot around with the robot base. You can see that the targets that are attached to the robot base do move with the robot base. And if we were to look here, we could see that if we were to collapse the robot base reference frame here, the robot and the targets disappear, meaning that those are all children of the robot frame, of the robot base reference frame. That means that if the robot base reference frame moves, they will move with it. I would like to have it at the origin of the reference of the station here, so that everything is at 0, 0, 0. In fact, if the base of the robot is at 0, 0, 0, that could simplify stuff later down the road. If I was to double click here on the reference frame, I could simply come here and enter 0 everywhere. Or if I want to save some time, I can right click the reference frame and click here simply reset. That will simply bring everything here back to 0, which is kind of useful. Now we have our path and we created it with joint targets, but let's say that it was a mistake. We want to create it with linear motion. In fact, sorry, I said joint targets, I meant joint motion. So I said that we want to use linear motion instead. So right click any target and you can select linear move. So that will transform the joint motion that you have to a linear motion. You can do that with multiple moves at a time. So in this case here, set move linear for all of those. And now if I run the program again, the yellow lines representing the path are indeed straight lines now. Talking about the lines themselves, you can make the yellow lines, you can make it disappear by right clicking the program and clicking display path or F7. That will remove the lines. You can do the same with the targets. If you right click invisible or F7, that will remove the targets. If you select any of those, you will see that it appears as kind of a semi-transparent target before the robot moves there. Small trick, if you want to select a target but you don't want the robot to move there for a given reason, you can press Ctrl and then press the target. That will make it semi-transparent so that you can see that selection is good, but it won't move the robot to that position. So that can be kind of useful if you bring the robot somewhere, you need to click on another target but you don't want to actively move the robot there because you already set the robot position or something like that. That's useful. And that doesn't change the fact that the robot can also follow the path, even if the target and the path are not displayed. So that's cool. That's the first thing. Second thing, let's say that we have some reference. I'm gonna bring that back here, visible. Let's say that we have a reference frame here that we create. So if we can click here, it will create a reference frame, which is another reference frame, another base, same way as you had one for the robot base. You now have another one called frame 2, and let's call it rectangle. Oops. Let's call it rectangle. So this will be the rectangle reference frame. First of all, I would always want my reference frame to be part of the robot base. So if I want to have reference frame to clarify stuff, position stuff in my station, I should always have kind of a master reference frame, which should be either a world reference frame or a robot base reference frame. So that's kind of your choice. I use both. I'm going to show you that I use both. So I'm going to go and drag and drop my rectangle reference frame to my robot reference frame. So here. And then I'm going to take all those targets here, right click, change support, and change that support for rectangle. Or even before I do that, I'm just going to make sure that the values here make sense. So double click the reference frame here. I'm going to just give it some rounded values. So minus 24, 0. So that's perfect. So just a way that it's not like with weird values here. So I'm going to redo what I was doing. So select all those, by the way, just so that you know, select the first one, shift, select the last one, will select all the targets. If you select just the first one, control, you can select targets individually or other items individually, sorry. So select corner 1, press shift, select corner 4, right click, change support, and then select rectangle. So that will simply take all the targets from the reference frame base you had, in fact all the targets you selected, and make them children of the reference frame rectangle. And then you can right click on rectangle here and select active reference frame. If you do so, the little green dot will appear on top of this reference frame, meaning that this is the one active on the robot at this specific moment. You can also know that by double clicking the robot and looking at what reference frame is active here and what tool is active here. Before we only had one option, so there was no ambiguity. But here, if you select here, you have now either the reference frame base or the reference frame rectangle. If you were to move this reference frame rectangle around, the targets would also follow. So now I'm going to do something that I know won't work, but I want to do it just so if I was to run here this rectangle program that we created before, that was creating a perfect rectangle right in front of the robot, that doesn't work anymore. It's telling me that some targets are unreachable, and it's creating the motion in a weird place while the targets are in fact here. So why wouldn't it try to reach the targets here? Why would it reach them here? The reason is that robots mostly work in a relative world, so not absolute, meaning that if you're feeding them a specific Cartesian position, it will be relative to the active reference frame. So here corner 1 is here relative to the rectangle reference frame, which is here. But if you were to activate the reference frame base and click once on target 1, it will bring it here. Why? Because this position with respect to the active reference frame, which is reference frame base, is exactly the same as this position here, corner 1, with respect to rectangle here, if this one was activated. So if I activate this one instead, right click activate, click once on corner 1, it will go to the right position. By the way, if I activate this one, double clicking a target will, like I showed you before, teleport the robot to this target, but it will also activate the linked reference frame. So if I double click here, now reference frame rectangle is activated and we are at corner 2. The reason why running rectangle here bring us to that position is kind of related. This is because here by default, remember where RoboDK, when we created that program, RoboDK created automatically a reference frame that was linked to the robot base. This is still here, so we need now to tell that program that this new reference frame that we want to use isn't reference frame robot base, but now reference frame rectangle. So right click, set reference link, and then we go to rectangle, just like that, and then we run that here. And now we can run the program properly. See that yellow line here? So that yellow line will disappear the next time I double click on rectangle. Why is that? Because in robotics, in fact, to do a motion in life, you need to have a starting point and an ending point. In robotics, the starting point is always the current position of the robot, and the ending point is wherever you want to go. So therefore, every time you launch a path, it will take the position of the robot as the first point to draw the trajectory of that motion. So if I was to double click it now we're starting from that point here. So our yellow line is here. If I was to bring that here, double click, now this is part of the path. If I bring it, doesn't matter, double click here. If you right click, you can click on loop also to make it a loop. So this way it will simply do the same program over and over again. So that's always potentially cool. Right click, run to remove it, loop. By the way, if you want to stop a program at any point, you can either right click, press and run. That will stop it, or good old hitting escape a few times should bring you the same exact result. If you launch a program like that, put it in a loop, let's say, and if I was to move that frame around, the path would follow that frame. And now I hit a singularity, so that's not great. But yeah, I can move it around quite a bit as long as I'm still in a space where the program is actually possible. If I double click the robot while it's running, I can see the actual position of the TCP at all time. Can see the position of the joints at all time, configuration, and all. So that's pretty much. Oh no, I have another thing to show you which is very, very important. Let's talk about configuration real quick. So right click loop here. If I press F, let's say double click on this first corner one here, I'm going to press F3, bring that target panel here. I'm going to go to the second position. I'm going to go and mess up things on purpose. So let's see that you didn't, let's say that you didn't see what I just did here. So perfect. Let's say that you didn't see anything, okay? So let's double click on corner one. Real quick, what are configurations? Configurations are a way, or in fact, a set of ways for the robot to reach a given Cartesian position, so XYZ position, given a certain set of joints. So let's say if we are in this position, if we are at that position here, corner one, I'm gonna bring that to the side here. We used one given configuration, which is having the robot in front of itself, elbow up, and wrist non-flip. So what I mean is that we are pretty much like that. If I go to other configuration here, I click on that drop-down menu, you will see that you have 8 other opportunities, so from 0 to 7. If I was to select one specific, you will see I'm at the same exact position, but my robot flipped a bit. And if I go and do I have another option? Yeah, potentially 2 would be a better option potentially, because it's a bit farther away. So in this case, I have 12 different configuration, including, let's say, this one here. So the way it was before and that configuration for the robot at the end of the day are the exact same XYZ and then rotation position. But the configuration isn't the same. So that's important to, first of all, know that you can have multiple configurations for the same Cartesian position, but also how RoboDK behaves and how robot behaves in general with regard to configuration, because you have multiple choices and therefore the algorithm behind RoboDK or behind the controller needs to select one of the configuration and say, I'm going to go for this one. So how it works, like if you double click a target, it will, like I said before, teleport to that position and activate the right reference frame, but it will also select the right configuration you have. So you can see here, if I go to corner one, I press F3. Kind of surprise here. Oops, okay, I didn't updated that. Okay, so forget about that. I'm gonna go and teach current position. Yeah, it's because I moved stuff around a bit too much. So if you double click corner, if you open corner one and it was how you created the program in the first place, double click here. The position of your joint here in the joint axis should match with the robot joints you have here. So, and indeed they match. So if I was to be in another configuration like that, I don't know, let's say here, and double click on corner one, the position, the configuration I have here, or the joint values I have here, will be translated to this section here. So that's awesome. But if I was to be here, let's say, with that configuration and click once on corner 1. Oh yeah, no, I'm not in the spot where that works. I would have to be a bit further away, I believe. That if I click once here, yeah. So if I'm in this configuration instead, and I click once on corner 1, it will go to corner 1, but with that weird configuration. But if I was to go back to corner 2, double click on corner 1, now I'll have the right configuration. Why is this? This is simple. Linear in robotics in general, linear motion do not respect configuration, joint motion do respect configuration. And clicking once on a target is the same as doing a linear motion, and double clicking on a target is the same as doing a joint motion. So therefore, clicking once won't respect configuration, clicking twice will respect configuration. So if you were in a situation where you were like scrolling through the targets like that, and then the configuration would stay just fine, and if you were to run your program in linear motion, everything would be just fine too. But if you were to select all of that and make it a joint motion, or if you were to double click on once, you would end up having some weird situation like that. So that's why it's important to make sure that your configuration works here, and there's an easy way to fix them if it doesn't work. If you go to the first position, let's say you can go to this first position here, make sure that this configuration makes sense for you. You can click on corner 2 once. This will create a linear motion without configuration, without bothering about the configuration. If I press on F3 to show you this target panel, you will see that the joint values here recorded with that target do not match with the joint values recorded, the joint values active on the robot. But if you click on teach current position, now it will gather those values here and add it there. So if I was to just go back to corner 1 and then relaunch rectangle here, you see that we had that weird line here to go from there to there. If I was to do that, this one disappeared. So now we just have this one to deal with. So in fact, we're using the fact that just one click does not respect configuration to go from one to the other with the closest configuration. We record that configuration. We go down to the next one, right click, teach current position, same exact as pressing F3 and teach current position. And then F4, right click, teach current position. And then now if we run that, we have a nice looking program with just move J that do not go behind the back or weird wrist flip and stuff like that, because the configuration that are attached to those configuration that are attached to those targets are, let's say, well recorded or recorded with certain logic behind, so that it makes sense. Okay, that's pretty much everything for this video. I hope it was helpful. In the next one, we'll create a bit of a bigger program with a feature called Teach on Surface, and we'll start using calling subprograms and being able to use move Cs and so other features that are available with RoboDK within, let's say, the basic package or basic feature that you need to use very often.